Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. In my last video, I had talked about surface areas and volumes, and in that video, predominantly talked about surface areas. Today, let's learn about volumes. Whenever you think of volumes of any given container or in any given shape, we should think volume in either of the two ways. If a substance has been given to you or a solid shape has been given to you, which is completely filled up solid, like a cube, which is solid cube, completely filled up with the same material inside. Okay. Then you should think in terms of volume of the material involved to create that shape. Okay. Whereas if it is in the shape of an empty container like a cube, but it's an empty cube, okay, then you should think of volume in terms of how much of liquid it can hold. Suppose it's a cubical container, then how much water it can hold and the volume of that water. Okay. So that's how you should think volume of a given solid. If it is completely solid material, completely filled inside also, then you should think in terms of volume of the material. Whereas if it is an empty container of that shape, then you should think in terms of how much volume of liquid it can contain. Okay. Let's look one by one all those standard shapes and how to calculate the volume of the solid or volume of the shape. Let's take the first example of cuboid. So let's draw the cuboid. The dotted line shows those edges which are not visible from the front. The solid lines are the edges which are visible from the front. If length of the cuboid is L, breadth is B, and height is H, then the surface area of the lower portion of the face is equal to L into B, because that is a rectangular shape. Okay. And you keep stacking the similar kind of surface area of the faces up to a height of H. That will give the volume of the cuboid. So volume of the cuboid will be equal to the surface area of one face, and the similar faces you keep stacking up to the height of H. That will give you complete volume of the cuboid. Okay. Now, as I had told, that consider the volume of any given shape in two terms. If it is a completely solid stuff, this entire cuboid is filled with the same material. Suppose it is iron cuboid and it is completely filled up of the iron. That's how you get a complete solid cuboid. Then the volume of the material, that is the iron involved, will be L cross B cross H, L into B into H. That will be the volume of the cuboid. If it is just an outside container, not a completely filled solid, and in that you can pour some liquid and store some liquid, then also you can think in terms of the volume of the cuboid. That is the volume of the liquid it can contain, and that value also will be equal to length into breadth of the lower surface and how much is the height of the cuboid. So L into B into H. As I mentioned earlier, volume always you need to think in these two terms. If it is completely filled up solid, then the volume of the material involved in creating that solid. If it is an empty container, then volume of the liquid it can hold. In both situations, the volume equation will be L into B into H for a cuboid. Similarly, if it is a cube, then we can draw a cube like this. And this is the dotted line because this is not visible. The side of the cube is A, and A. And therefore, again, A into A will be the surface area of the lower face multiplied by the height A, and this becomes the volume of the cube, which will be equal to A cube. Again, the same fundamentals applies. If it is a solid cube, then the volume of the material involved in creating this cube will be equal to A cube. If it is an empty container of cuboidal shape, then rather cubical shape, then it will be A cube. That much of volume of liquid it can contain. Okay. Let's look at the next shape, that is the cylinder. Now, if it is a cylinder of radius r and height h, then the circular area is pi r square, and this circular area, suppose this is a one kind of solid circle, and in that you keep adding those solid circles up to height h, then you will get the volume of the material involved in making this solid cylinder will be equal to pi r square, which is the surface area, multiplied by surface area of one circular face, the lower face, and you keep adding up to height h, and that becomes pi r square into h. That much will be the volume of the material required to form this shape of the cylinder, which will be a solid cylinder. And as explained earlier, if it is a empty container, then the volume of water or any liquid it can contain is also equal to pi r square into h. Okay. Now let's look at cone. The volume of the cone of radius r of its circular part, the radius r, and the height, this height is h, then the volume of the cone will be equal to 1/3 of pi r square h. Okay. Also understand, we had just learned that volume of a cylinder is pi r square h, whereas volume of the cone will be 1/3 of the pi r square h. Has it been an empty cone, then you can pour water into it. Okay. And if there is a cylinder of the same radius and same height h, you can pour 3 such set of water contained into cone. Suppose you filled up this with water and put it will get filled up to here. Then again you take water filled up into this cone and pour into this, it will fill up to here, and then again you take third time, it will fill the entire cylindrical container. Okay, so that's how the relationship of this volume of the cone being 1/3 of the volume of the cylinder, which was pi r square is. So as a formula, you need to remember that volume of the cone is equal to 1/3 of pi r square h. And as explained earlier, if it is a complete solid, then this is the volume of the material required to form this solid. If it is an empty container, then this is the volume of the liquid which it can hold. Okay, let's look at the sphere. So for a sphere, this is a sphere, not a circle. This is a three-dimensional figure, which is sphere. So volume of the sphere is 4/3 pi r cube, where r is the radius of the sphere. And the same funda applies. If it is solid sphere, then this much of the material will be required to cast this sphere. If it is an empty sphere, then this much of liquid it can hold. Okay. If it is a shape of a hemisphere, then it will be appearing like this. It will be appearing like this becoming the center, and this is the radius of the hemisphere, and then the volume of the hemisphere will be equal to, because it is hemisphere, half of the sphere, so it will be half into the volume of the sphere, which is equal to 4/3 pi r cube, and therefore this becomes 2/3 pi r cube. That is the volume of the hemisphere. And as explained earlier, if it is a solid hemisphere, then this much is the volume of the material required to form this solid hemisphere. If it is just a container in hemispherical shape, then how much of the liquid it can contain, and that will be the volume of the liquid, that is 2/3 pi r cube. Okay. So with this explanation, you might have understood by now that how we need to calculate the volume of these ships. Okay, in our next video, we will talk about some of the numerical examples. Thank you.